Hello everybody, welcome to Cafe Scientifique Silicon Valley. My name is John McIntosh. I'm here with Roger Whiting, who is the helped found this. We always start this off by expressing our heartfelt thanks to SRI International, who opens up their whole conference center to us, makes unlimited amounts of coffee, and gives us sweets to eat, and really makes a cafe like this possible in the first place. So thank you for opening your doors and all the generosity you've shown us over the years. I want to let everybody know we really covet your speaker ideas and topics on new ideas in science and technology that you'd like to hear about, or specific ideas for speakers are really welcome. So if things come to you, you can always contact me at the address shown on the screen at John McIntosh at Cafe Sci, or at events. Just reply to the emails that go out if you get those. You can also, if you're feeling adventurous, go to our Facebook page and leave comments there, or just go to our homepage and there's a link for filling out a form for your ideas. Tonight's speaker was actually came to us from Kay Brown. Kay, if you could stand up. Thank you very much for making the introduction. She knew that, she would be an excellent speaker, and organized kind of the meeting online where we were able to cross paths. So this wouldn't have happened without for Kay. So thank you very much. Upcoming events next month, April 10th, we have Penny Eckert from Stanford University, Department of Linguistics, and as it turns out, girls and young women in their teens and 20s are really the pioneers in terms of the vocal trends and slang that we use. So if you've ever wondered why we talk the way we do, or if you've ever seen a middle-aged dad like me who tends to speak in uptalk and ends everything as if it's a question, if you agree with me, come to this. And there's emerging things that are coming out, like things that are called vocal fry, that are hilarious but are kind of spreading around. And come to it at least if you want to learn things and just really freak out the teen and 20-year-old girls in your midst with your knowledge of the emerging trends and what's cool in terms of dialect. So tonight I want to get right to it. We have Professor Frank Chu. We're very lucky to have him here. I'm not going to spend too much time going over the areas of his research, the awards he's received, and kind of just generally the distinctions that he's been given. It would eat into too much time. Suffice it to say, I'm going to cover the high-level highlights. He's a professor emeritus at Berkeley. He was given the title of University Professor, which is a UC system-wide designation that's only been handed out a few times, given to people with distinct international scholars and who are exceptional teachers. He's also the Distinguished Research Fellow in Astronomy and Astrophysics at Academia Sinica in Taiwan, where he spends half his time. So we're, again, very thankful that he's here today to talk about a subject that we've been trying to find an expert on for quite some time. So without any further ado, I'm going to turn this over to Dr. Xu.
Thank you very much, John. This talk is dedicated to the young people in the audience as well as the retirees. I've actually retired 3 times, okay? And I think that it's us who have the most freedom to speak out for those who cannot speak out, all right? And we have, I think, an obligation to do so, given the crisis that is climate change. I'd like to begin by, again, acknowledging Kay Brown, Byron Brown, Bob Green, David Harris, and John McIntosh for helping to arrange this talk and giving advice on what might interest people. So the outline of the talk is the following. First, I'll give a brief review of climate change. I'm sure everybody's aware of it, but I want to emphasize some aspects that are not emphasized enough. And basically it comes down, climate change, that all the difficulties are the 3 E's. They're closely coupled together: energy, economics, and environment. Then I'll review one of the primary means by which we can address this issue. Many people feel we can address a review of nuclear fission, but its history is basically a sad one. It's what I will call the disillusion of the light-water dream. And then perhaps a second age where molten salt reactors and thorium can play a safe, secure, and sustainable role. So that's the 3 S's, 3 E's, 3 S's. If you remember nothing else, this is what I want you to take home with you. And then I will talk about molten salt as process heat, in particular to convert biowaste to biochar and biosyn, that's 3 B's, to roll back climate change. So if this talk is technical, somewhat technical, at least in its middle stages. So if you don't remember many of the slides, this is the one I want you to remember, okay? That is that right now the subject of energy is become so rancorous and so vitriolic with every proponent of one technology or another, so having nothing good to say about others. So we are basically in a policy gridlock. And this gridlock has only been exacerbated by Fukushima. So what I'd like to suggest, and many people in particular, there's a group called the Thorium Alliance who has passed around some some brochures that you may pick up, have been advocating is that we consider a new way to do things. And I just want to contrast that with this slide, where most of the policymakers, most of the nuclear power infrastructure and industry is pointed toward light water reactors, the best example of which are called the Generation 3+ reactors. Recently, the Westinghouse AP1000 has gotten into the news about this, and they are distinguished from what some of us feel are much better reactors, but none of these have been constructed yet. They're all paper reactors, Generation 4 reactors. So some of the contrasts is the Generation 3+ are solid fuel elements, as we'll discuss. They use water as a coolant, and because they need lots of water, they have to be sited near the coast, near oceans, or along rivers where people like to live. And so if you have accidents, they have tremendous consequences. Whereas the molten salt reactor, one of these Generation 4 reactors, are liquid-based fuel, salt, and use molten salt as a coolant. So they don't need water. And they can be sited in unpopulated areas, like deserts, okay? So if there's an accident there, it has much less consequence. The way we use uranium today is such that if we use it at the current level, which is about 6% the total energy, then it will last about 100 years. And often when I talk to my friends who think 6% is good enough, I say, well, then you have a responsibility to tell me what's the other 94%. If there is another 94%, why should we use nuclear energy? Why don't we just use 100% of that? If there isn't 94% and you have to use nuclear energy at 100%, then it only lasts 6 years. What's the point in that? Okay. Well, thorium-based reactor, this reactor, you can use it at 100% of the total energy. Of course, other things would help, but in a worst-case scenario, if it had to be used at 100% to provide all the energy, it would last 2,000 years. And in 2,000 years, we better have a better solution, okay? Hopefully it's fusion. If it's not fusion, then we should kick all the plasma physicists out of universities. Okay, the waste storage in light water reactors, where you use uranium, is complicated by the fact that you automatically generate plutonium for reasons that I will explain, and that plutonium causes all the problems that we have today. In particular, it has a half-life of 24,000 years. If you want to store it so that it drops below background, you have to store 10 half-lives. That's 240,000 years. Nobody can guarantee that we know how to store things for 240,000 years. If you use thorium, on the other hand, you never generate any plutonium. So the longest half-lives are the fission products, 30 years. That means you only have to store 300 years. And we have known for many thousands of years how to store things for 300 years. In fact, if you go to China, you go to Egypt, you go to Greece, 4,000 years ago, they knew how to store things that are transmitted safely to us today. Because we have plutonium in the light water reactor business, we have a proliferation risk. Some of this could be stolen. And although it wouldn't make a very good bomb, it could make a very dangerous, dirty bomb. This reactor on the right-hand side is plutonium-free, so it doesn't have nearly the same proliferation risk. Also, as we'll see, as in Fukushima, occasionally you get what are called station blackouts. That is, you have no power, and you still have to cool the fuel rods, even though the reactor is shut off. Well, the new reactors are such that automatic mechanisms kick in. You have 3-day reprieve, but if after 3 days you still have a problem, then we have a big problem. Whereas the molten salt breeder reactor, we want to design so it's walk-away safe. That is, in the worst of all possible accidents, you lock the door, you shut it, you go away, nothing bad happens. It's all trapped. Here's some items that are personal opinions, not universally accepted by everybody. But the way we use nuclear power today is almost confined uniquely to generating electricity by turbines. And I will explain why it's difficult, even for nuclear power, to compete with fossil fuels when you do that. On the other hand, if you use it as process heat, it is possible to bring the cost down so that it becomes cheaper than gas, cheaper than coal, rather than more expensive than coal, more expensive than gas. Finally, a big problem with the way we use reactors today is nuclear waste. We generate more and more of it around. We basically use 1%, try to throw away 99%, and we're not even very good at that. Okay? So we get more and more of it. Whereas, because we don't have this problem, we can actually use it to ameliorate the environmental problem of municipal waste with molten salt reactors. In other words, as I'll show, we can actually make things carbon negative by turning what is today garbage and other kinds of waste into a resource. Okay? Nuclear power today is carbon neutral. That's very good, but it's actually possible to make it carbon negative.